Hello my dear friends. I am your narrator Mr. S.M. Welcome to another interesting video. Can we survive on Mars? Future of space evolution. It seems like everyone has Mars on the mind these days. NASA wants to send humans to the red planet by 2030, and SpaceX wants to get there even sooner, with plans to have people there by 2024. Mars is a favorite theme in Hollywood, with movies like The Martian, but most of them aren't addressing the biggest questions. Once we get there, how will we survive long term? Let's look at the challenges first. The diameter at the equator of Mars is about half that of the Earth. The circumference of Mars is also about half that of Earth. The volume of Mars is 15% of the volume of Earth. Mars is not just smaller than Earth, it is also less dense. Though Mars is 15% of Earth's volume, it is only 11% of Earth's mass. This means that the pull of gravity on the surface of Mars is only 38% as strong as the pull of gravity on Earth's surface. Mars spins a bit slower around its axis than Earth, so each day on Mars is a little longer. It lasts 24 hours and 37 minutes. A year on Mars would be 687 Earth days. Earth's atmosphere has 78% nitrogen and 20% oxygen and small amounts of other gases, including carbon dioxide, 0.04%. People could not breathe the atmosphere on Mars. It is 96% carbon dioxide and only 0.145% oxygen. The Martian atmosphere is also thin. This means that it is 100 times less dense than Earth's atmosphere. Both Earth and Mars experience 4 seasons. Each season on Mars is longer than each on Earth because the Martian year is longer. The climate on Mars is colder, drier, and harsher than in any place on Earth. Earth's average temperature is 14 degrees Celsius, but the average temperature on Mars is a chilly -63 degrees Celsius. A vast ocean system of liquid water covers 71% of Earth's surface. There is water on Mars too, but the cold temperatures and thin atmosphere mean that liquid water cannot exist for long. At least not on the surface of the planet. There is evidence that salty water flows in some places on the Martian surface. But this only happens when the temperature is above -23 degrees Celsius. Mars has solid water in its polar ice caps like Earth does. There is also ice just below the surface of the planet. A tiny amount of water vapor exists in Mars's atmosphere, and there is water ice in its clouds. Just like on Earth, wind is a big part of the weather on Mars. Because the surface of Mars is so dry, dust storms are common. Strong winds, caused by uneven heating of the atmosphere, pick up dust from the planet's surface and cause dust storms. But, can we change this? Yet the fact remains that the astronauts will be unable to live on Mars except in very restricted conditions. They will have to stay inside their capsules, inside a base or inside their space suits. Mars is not suited to human visitors. Even if such a Mars we could live on can be achieved, it will take centuries, and the problems involved are only too clear. For example, we must thicken the atmosphere, changing its composition and making certain that it does not leak away, as the first atmosphere presumably did. Remember that the escape velocity of Mars is only just over 3 miles per second. We must also raise the surface temperature, perhaps by introducing greenhouse gases or by melting the polar ice caps. Persuading plants to grow on the surface of the terraformed Mars will be difficult, but can probably be done. Eventually we will end up with a Mars where there are large cities, supporting a population of thousands or even millions. A terraforming program would be vastly expensive by any standards, and would strain the resources of even a wholly united Earth. Building places to live on Mars poses a challenge. Transporting construction materials to Mars could end up being way too expensive. So, scientists propose the possibility of using materials from Mars to construct homes. Growing food on Mars won't look like the farms that we have on Earth. Instead, crops would need to be grown without soil, such as tank farming or aquaculture. This is where the food would be planted in nutrient-rich water and fed with artificial lights. NASA has been experimenting with MOXIE, an instrument that would convert CO2 to oxygen on Mars. So far, this instrument on the Mars Perseverance rover has managed to successfully create oxygen from CO2. This leads the way for bigger experiments and possibilities for air on Mars. So, before we can start to call the red planet home, we'll need to solve these problems. This is the end of this video. But, I am waiting for your comments. If you find this video interesting, don't forget to like, share and subscribe. Thank you again for watching. Bye-bye.